My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. And today we're going to be talking about a very exciting paper called the 3D Printing with 3D Printed Digital Material Filament for Programming Functional Gradients. Now, this is a thing that is one of these like really elegant things. So a team has just submitted this paper to Nature that consists of Sang-Joon Ahn, Howon Lee, and Kyo-Jin Cho. They're from Seoul National University. And what they've done is, well, they've basically taken a bunch of filaments, fed them through a 3D printer to mix them and feed them together. Then they end up having their what they call digital filament. They then feed that filament into a printer to get the right kind of characteristics in the second kind of print. So essentially, they're using filaments and the kind of arrangement of these filaments in a kind of two-step process to end up with gradient parts. And this is something that is interesting because it's an interesting way of doing it, and it's an interesting way of getting up gradient parts. What they've been able to do is kind of program material properties to a certain extent by mixing these things in this two-step kind of properties. Now, they hope to get to some kind of things like, for example, having variations in material properties, mechanical strength, electrical conductivity, things like that, have real kind of programmable materials or gradient type properties across the part. Now, the other thing is, of course, this is great if it works. We have to see if it works, but this would be great if it does work. But then, yeah, we can just use regular old filament. We can use printers. There's no real super expensive equipment that you need to do this. So if it does work, it's going to be applicable for a lot of people. A lot of people are going to be able to do it. Or even if new equipment has to be developed, it's going to be pretty simple to do so. So I thought this was really elegant. I thought this was really something that a lot more people have come up with. I think a bunch of people are going to be looking at this going, oh, wow, that's a really very, very interesting approach. And I think, I hope this will work because this will mean that you have more of an option to program your filament or program certain properties at a certain location at home, or at the office. And that's going to be very very exciting, I think. The next thing is, the Air Force Center for Strategy and Technology, they have something called a Blue Horizons mission, kind of like a contest type of mission kind of thing. And in that contest, a team consisting of something called the Black Phoenix crew, which is a bunch of fellowship students working with a company called Titan Dynamics at Elgin Air Force Base, managed to assemble 6 different aircraft in 22-hour period. Their idea is to rapidly use 3D printing to iterate, improve, and then assemble, and then hopefully successfully launch small UASs or UAV or drones, as they're called normally. Their idea is combining quick software integration with 3D printing is going to lead to drones that are quickly adapted. Now, this is a huge thing. We've been talking about that at 3dprint.com for many years now, because it means that if we need to increase the payload for some reason, we can redesign the drone at the battlefield and quickly improve them or print new ones to come up with that new circumstance and meet that new circumstance or challenge. If we need drones that are more maneuverable, we can change the wings, the wingtips, the control surfaces, make the things smaller, whatever we can do to get that about. So that means that you can iteratively improve your equipment in the battlefield. And of course, if you iteratively improve your drones every day to make them better, and the other guy isn't doing that, eventually you have a chance of winning, of course. So this is a very big thing. It's a very big thing specifically for the United States of America, because drones are excellent, but they usually take many years to procure and they cost many millions. Even like the low-cost drones in America are hundreds of thousands of dollars. Whereas on the battlefield in Ukraine, we're seeing drones of several hundred to several $1,000s make a real difference. So for the United States of America to compete in that arena and to let its allies compete in that arena, it needs a step change. And also, we all know that DJI dominates the desktop drone or the kind of inexpensive drone industry. If the United States is going into a conflict with China directly or proxy, the Chinese industrial base can put out tens of thousands of drones that are lower cost and more capable at the moment and easier to produce and cheaper than America could. America could not do this. Indeed, in Ukraine, a lot of the drones are using Chinese components on either side. So there has to be a path out of this, and the United States is trying to do this through programs such as this. So I think it's a good, very necessary development, because if the Chinese can put, let's say 100,000 drones somewhere and just keep 10,000 of them in the air all the time, how are you going to invade that territory? How are you going to make any kind of credible threat if they have these things and they can just print 1,000 a day to replenish them? It's simply just not going to happen. And another thing that is basically a little bit of a reality check, but it's quite nice actually, is this thing. What we see in front of us is a cabin. It's like a helicopter cabin. It's not actually a cockpit like a real cockpit. It's a cockpit for a flight simulator. This is done by a company called Reiser Simulation Training and Murtfeldt Additive Solutions. So Murtfeldt doing the printing job, of course. And what they use is fused granulate fabrication, but with a difference with variable nozzle diameter. Now, a lot of people have tried this. Roblox, I think, did this at one point a long time ago. And of course, it's beautiful, right? Variable nozzle diameter means that I can change ideal nozzles for the bead size, right? For maybe even a type of filament or granulate, right? Type of material. I can also maybe do a big nozzle on the inside of my part to get really high speeds, and then make it really like the same nozzle much smaller for the finer parts that need detail. They're going to be visual. So the potential there, this granulate fabrication, which of course we know the granulate fabrication is way cheaper than the filament, about factor 10 or something like that, depends on the material. That combination, so low cost, which really adds up. We've got a part here that's like 2 by 1 by 2 meters or something like this. That combined with this nozzle diameter could get you a lot of speed changes and can be a real interesting way. Now, variable nozzle diameter, for anyone who's tried to play with it, of course, is actually quite difficult because, of course, the pressure changes and the pressure buildup, you'd have to manage that. And that's, of course, really very, very difficult, actually. Now, in this case, normally it would take 2 to 3 months to manufacture these components in a conventional means out of lots and lots of different molds and stuff and milling and all this, or 3 to 6 months, sorry. They've done this in 1 month. The longest single print time part took 100 hours. So if you would serialize this, put a bunch of machines next to each other, it would be faster. But of course, this also tells us a little bit like, hey, wait a minute, if we're going to be wanting to make full-size drones, this is a lot larger than a lot of drones, but still, these are the type of print times that you would need. And this is if you're doing a filament or granulate, right? Rather than doing a powder bed fusion, stuff like that. So, a little bit of a reality check, I think, this is part. The part was printed in PAGF. PAGF is a fantastic material for large-scale manufacturing. It's one of the most popular materials in actually manufacturing using 3D printing at the moment. Polyamide, in powder bed fusion is used, but PAGF specifically, the glass fiber-filled GF, makes it more rigid, tougher. That is a huge material in manufacturing, much more so than people on the desktop. So the PAGF combined with a machine that maybe you haven't heard of, but it's really kind of cool. Actually, it's a Queen 1 system by Q.Big. I mean, the name is, I don't like it, but and I like it. It's a solid. It seems like a really solid system. It seems like a really industrial system. A couple of years ago, at Formnext, we had 4 or 5 of these companies all of a sudden come out, and all of a sudden we had 20 companies doing a kind of medium format space. We're talking 1 to 2 meters and that kind of thing. All of them kind of with very industrial, very kind of high quality, long lasting, something very German, if you will, machines. And it was looking like a really exciting market because the applications for this. There's huge. There's many things that are just really low volume, really low series, and that it would take much too long to do with conventional manufacturing. So the business case is here. We don't know if a lot of these manufacturers are going to really survive, but if they find these types of applications and these types of use cases and stuff like that for this kind of this filament-based or granule-based printing, this could be a really interesting market segment, and also an interesting market segment to explore for traditional service bureaus. You can see in the back of this system, you can see, I think that's what is an AOS 500 or P3 or something on the back. So this is a traditional service bureau that is doing this on the side, that is turning to filament or FDM essentially, or kind of granulate GDM or whatever we call it, granulate deposition processes to make these large parts, which are of course going to be much more cost effective than doing the same thing with a powder bed fusion part. Now, how do they find these applications? That's the difficult thing. How does that company making that cockpit for the flight simulator find Murtfeldt and the other companies that are doing this 3D printing? That's going to be difficult, but if they do find, I think this kind of stuff, all these custom large-scale parts are a huge new application, new area. Anyway, my name is Joris Peels. This is another version of 3D Printing News Unpeeled, thanks to 3dprint.com. I hope you enjoyed this and found this